Section 2.5, find probabilities using tabled data. We have previously found probabilities. You know how to do this. If you don't, it's okay. Look back on your notes, or in this section, we also give you a definition. The difference in this section is we're going to be using tabled data. We're going to be looking at a lot of tables. So bringing back an idea that you saw in section 1 and the probabilities that we saw at the beginning of section 2. So here's a definition. The probability is defined from the following formula. The probability of E, I hope that you've been noticing that we always use P for probability. And then E, in this case, stands for event. So how do we find the probability? We use the frequency of the event E in the numerator divided by the sum of all frequencies. Sum, you've seen this word before, and we use the word sum with the symbol sigma. So all of the things you've been learning all semester are coming back. So the sum of all frequencies. So in short, this formula, probability of an event, which is the frequency of event E divided by the sum of all frequencies. The short version is this. Well, all in all, I want you to know that this whole thing here is the same thing, right? I always want you guys to know that these all stand for the same thing. From the left to the middle to the right, all the same thing, different ways of saying it. And then we have our last statement. It says N. Remember, in words it says a sum of all frequencies, but the shortcut is N. So N stands for the sum of all frequencies. So it's the same thing over and over. If you didn't learn it before, this is your chance to learn it now. Let's take a look at our first table. A company is conducting an online survey of randomly selected individuals to determine if traffic congestion is a problem in their community. So far, 320 people have responded to the survey. So you're usually going to see the total in the problem, or if you come into the table, it's already there. If it's not given to you in the table, then you must come over here and look for it, or you must total everything. So again, in this case, they give us the 320, it's here, and if I look at 123 plus 115 plus 82, the total is 320. This is what sum of frequencies is. Let's go ahead and take a look at the questions. Leave the probabilities in fractional form. How many people responded that traffic congestion is a serious problem in their community? So we're just looking for people. 123 people responded. Serious problem. Find the probability. Take a look at the big difference in these questions. This is how many people. So we just answer something simply like 2 people, 3 people. This one does not say how many people. It says find the probability. Therefore, we're going to have a little bit more math. Find the probability that the next person that responds to the survey says the traffic congestion is a serious problem in their community. So we're going to take probability is equal to the frequency of the event divided by n. So what's the frequency that it is a serious problem? 123. You said it in the first part, and if you look back on the table, it says 123. And then what is the sum? N stands for the sum of all frequencies, 320. Let's try this again. How many people responded that traffic congestion is not a problem in their community? Again, we're looking for people. Again, we're looking for people. And not a problem. Not a problem is 82. The second part of this says find the probability that the next person that responds to the survey says that traffic congestion is not a problem in their community. Oh, I put an A earlier as well, and it should be an E, really. And so we're looking at the frequency divided by the sum of all frequencies, and the probability is A2 divided by the sum of all frequencies, which is 320. In this case, we see that it is divisible by 2 because they're both even numbers. So let's go ahead and start the simplification process. You must always simplify. So I'm going to divide by 2 here and divide by 2 here. 82 divided by 2 is 41. 320 divided by 2 is 160. And then we check again. Our common numbers are 2, 3, 5. I check 5 by looking at the end. Do the numbers end in 0 or 5? Not both of them. I check 2 by checking by checking if it's even or odd. One of them is even, one of them is odd, so they're not going to be divisible by 2. And lastly, I check 3. I add up the numbers, so 4 plus 1 is 5. 5 is not divisible by 3, therefore these numbers are not divisible by 3. And we have our simplified answer. How many people responded that traffic congestion is not a serious problem in their community? So this one's very different than the other ones. It says, so first of all, we're looking at how many people. So you're just looking for a number, not a probability. And then it says, not a serious problem. And when I go to my table, this is not in my table. There's serious problem, and there's moderate problem, and not a problem, but none of these say not a serious problem. So if this is serious problem, then these must be not serious. Remember, we just practiced that in the previous lesson 2.4. So moderate problem and not a problem, both of those are considered not serious. We would have 115 plus 82, and that gives us 197. Think it's not a serious problem. Now let's go ahead and find the probability that the next person that responds to the survey says that traffic congestion is not a serious problem. So we're going to take the probability of the event is equal to the frequency divided by the sum of frequencies. So we have 197 divided by 320. Let's look to simplify. Are they both even? No. Do they both end in 0 or 5? No. If I add them up, is it divisible by 3? 1 plus 9 is 10. 10 plus 7 is 17. Therefore, this is not divisible by 3. And this is our final answer. Great. You are going to try number 2. And I'm going to give you a big clue already. You do not have the sum. So you need to find it. But all the questions are very similar.